everyone. So next we are going to learn about what is multi-threading and how it is getting implemented in Java. First, we need to understand why multi-threading. Multi-threading basically makes your application or different methods to run parallelly, thereby increasing your overall resource requirements and overall time period that is required to implement my application. It also makes your application performance and more responsiveness of your application better. So let's understand more into it now. So multi-threading can be implemented by creating threads in Java. So what are threads? Threads are nothing but my program in execution. So within an application, we can create multiple threads. So we can say that these are the different methods which will be getting executed in parallel. But for that, each method we have to individually create the threads also. So the first part in implementing multi-threading in Java is to create the thread. Now there are two major ways using which you can create threads in Java. One is by extending your thread class. So we have a predefined thread class in your java.lang package. So we can inherit that thread class and then we can override the method that is part of your thread class called as run method and define the logic that needs to be executed in parallel for my thread. The second way of creating the thread is by implementing your runnable interface. So we can create a class that implements your runnable interface in which again we are going to override your run method. So this run method which we are going to override here can also be overridden with the help of your lambda expression because your runnable interface is a functional interface. Thread instantiation, once you have created the logic, that is your thread class logic or your runnable interface logic, you need to create a new thread object and you need to start that thread. You need to indicate that my thread has to start. We never call the run method directly because calling the run method directly is same as calling any normal method and my execution will be happening sequentially in that case. For the parallel execution that we want to implement using threads, we always start my thread using the thread function. So what exactly is going to be done when we are using the thread class for creating of my thread? So it is like subclassing your thread class. To create a new thread, we can extend my thread class. So you need to define a new class which inherits your thread class. And what you need to do is you just need to override your run method. This run method is going to contain the code that will be executed when the thread is started. Advantage that we get is by extending the thread class, it provides you a direct way, so you can directly create the instance of this new class that you have created because that class itself has become a thread class only, and most of the properties and the methods or the functions that are part of my default thread class are also becoming available to my current thread class. By extending the thread class, you can take the advantages of all thread specific functionality. So whatever is applicable on your normal thread class will now be applicable on your class also. So this is just giving an example of how your thread will be getting created by extending a thread class. So you have a class, my thread, which extends thread. You have a run method which you are going to override. So here in my run method, I'm giving the code that my thread is running. Now how exactly this code will be executed parallelly? So we are going to start my main method. In the main method, I'm going to create the object of my thread. Now I am creating an object of the class which I have extended because this class itself has become a thread class because of extending. So I'm creating an object of my thread class and then I'm saying start the thread. So as soon as you say start the thread, this thread will be executed. So my JVM will start executing my thread by executing the run method. So JVM calls the run method by itself. You never give a call to the run method. The next way of giving the score for my thread is with the help of your runnable interface. So implementing runnable interface gives you a very flexible approach. Implementing the runnable interface provides a flexible way of creating the threads by allowing you to use the same logic for multiple threads because you are creating another class in which you are providing the implementation of your run method and the same run method can be utilized by multiple threads if you want. Separation of concern by separating your thread logic from the main class. The runnable interface promotes a more modular and maintainable design wherein whatever the changes are required will be required in your run method. In the interface, you can directly jump and you can manage your code. Collaborative development, your runnable interface facilitates the collaboration as multiple developers can work on the different parts. Because it's an interface separated from my main class, multiple developers can together or create multiple run methods. That is also fine. So you can have multiple threads with multiple different functionality by creating multiple different interfaces implementations here. So you can use lambdas also to do this implementation. So this is giving an example of how my runnable interface will be used to provide the implementation for the run method. So I'm creating a class called as myRunnable implements runnable. Only one method is present within my runnable interface, that is run. So we are overriding that method. Now how to associate this runnable interface method run with my thread class? So while creating the thread object, we are going to create the object of this class which is implementing my run method, so that when I'm going to start this thread, it knows, my JVM knows that this is my class which is containing my run method which we have to execute. Now to provide the implementation for the runnable, we can also do it using the anonymous class and also using a lambda expression, because as you must have noticed, runnable interface is also a functional interface having only one method declaration into it. Every thread that we are creating in Java goes through a life cycle. So what are the different life cycle points that it crosses while it is being executed? So the first life cycle point that it comes across is a new state. So when we create an object of a thread class, the thread is actually existing in this state. So when a thread is first created, it enters a new state waiting for you to be started, for you to define that start functions. The next stage is your runnable stage. So once the thread is started, so once you have executed that start method, your thread will enter the runnable stage where it can be executed by CPU. It is waiting for its turn to come because there will be multiple threads that are going to start. So not all the threads will be immediately taken up by your CPU for the execution. So all your threads have reached a runnable stage. Now my JVM will come across these particular runnable stages and will pick up one thread and will call the run method corresponding to these particular threads. So the next stage that will be coming here, other than this, we have here the block stage also. Block stage in the sense when my thread will be getting blocked because of some lock assurance, because what happens is when we are implementing synchronize and all, we are locking our resources. So when my one thread is already working with a resource, my other threads will have to wait. Or we are making a thread go into the sleep mode, so that time also it will enter into the block stage. So a thread enters a block stage when it is waiting for a resource such as acquiring a lock. There is a waiting stage also. A thread enters a waiting stage when it is waiting infinitely. So it's in the block stage, but after that, after sometimes it will move into the waiting stage because there is no resource release. So in the waiting stage, it will just move infinitely there for another thread to perform a specific action. Actions like your join function or your yield function, where you are telling that okay, now my task is done. Another thread can come and complete this task. Time waiting stage, a thread enters a time waiting stage when it is waiting for a specific amount of time, such as when you are using the sleep function. In the sleep function, we specify the time for which my thread has to be blocked. So that time it will move to the stage. Terminated stage will be existing when my thread's task has been completed. So thread enters a terminated stage when it has completed its execution or it has been stopped. These are some of the basic methods that will be used in the thread execution. So you have the start method that starts the execution of the thread and move your thread into runnable stage. Run method defines what exactly my thread is supposed to do. Run method, we will not call it as a developers. Rather, the run method will be automatically called by your JVM when it is going to take your thread for the execution. Then we have the join function. Join function will wait for the thread to terminate. It will block the calling thread until the target thread has finished. So it is going to make the other thread wait till my task is getting completed. Your sleep method is basically used to make your thread go into the sleep mode, and while you are going to make it go into the sleep mode, you are going to specify the time in milliseconds of how many time period it should be going into the sleep mode. Here we are just explaining one of the example related to your sleep and your join function. So what we have done here is we have created here one class which extends the thread class. In the run method, what we are doing is we are implementing this statement where we are printing the current thread's name. So there is this method called as current thread which gives me the name of the thread that is executing, and it's also going to make my thread go to sleep for 1 second. 1000 milliseconds is equal to 1 second. In a catch, if let's say we are interrupting a thread in between, So there will be an exception thrown on my sleeve, that is my interrupt exception. And because of the interrupt exception coming place, my catch part will be executed in which we are printing that my thread has been interrupted. In the main function, what we are doing is we are creating two objects, that is T1 of my thread class, T2 of also my thread class. Then we are printing that I am going to start the state. So first I am checking the state of my T1, that is get state will give me the status new. So currently my thread is in the new state because we have not started it. Now we are starting both my threads. So I'm saying T1 dot start, T2 dot start. So both my threads will move into the runnable stage. System.out.println thread T1 state after start. So after start, if you will check, it is in the runnable state. So first it will go to new state, then it will come to your runnable state. T1.join. Now what exactly this T1.join? Now one thing you need to notice before this, T1.start and T2.start. T1.start will give a call to my run method. In my run method, it is going to print the statement saying that my T1 thread is running, but it will go to sleep for 1 second. Till the point my T1 thread is sleeping, my second thread will come and do the same execution of my run method, print the statement, it will also go to sleep for 1 second. Here we are executing one more step here, that is T1.join. So maybe the task of my T2 is not yet completed or T1 is not yet completed. We are assuming that. So what my T1.join is going to do, T1.join is going to say that let's wait for T1 to finish. We have put T1 into sleep for 1 second. We have put T2 also for sleep for 1 second. So I'm just saying that my main thread should not get completed. This is my main thread. It should not get completed till my T1 thread task is not completed. Once my T1 thread task is completed, let's all the other tasks to be completed. So join function will just make all the others to wait till this particular T1 thread task is getting completed. Once all the thread task is getting completed, then we will again check the state. Then we will check the state of my T1 thread also. We are saying here, since my T1 thread is completely done because we were waiting for its task to be completed, we are assuming its task is completed. Here the state will become terminated. Then T2 dot interrupt. Now here my T2 is still sleeping for a task to be completed. So it is sleeping and in between we are interrupting its sleep. And because its sleep has been interrupted, here in this block, interrupt exception will be executed and because of that my code will stop and it's going to print the statement that is my thread has been interrupted. So this is basically just showcasing some of the functions that can be utilized on your thread class. The other major concept that we need to understand here related to the threads is synchronization. So when we are talking about threads, multiple things are going to happen parallelly on a method or a code block. But sometimes we may want to restrict this. We want to say that no, I don't want multiple threads to be executed on a code block. We want only one thread at a time to come and get it executed. So for that, we can implement the synchronization. So synchronization is a crucial concept in multi-threading programming, ensuring the thread safe access to the shared resources. It involves coordinating the execution of the multiple threads to avoid the race condition wherein my threads are racing across each other to get my particular resource, and also ensure that my data is proper, my data integrity is maintained. Sometimes what happens when multiple threads are trying to access my shared resource, one thread makes a change, second thread is not aware about that change. It will come and make its own changes. So because of that, the end result which I'm going to get might be completely wrong. So this we can avoid with the help of your synchronization. So synchronized methods are thread safe in the sense at a time only one thread can come and do the execution. All the other threads, even if they want to execute this method, they will have to wait. So only once one thread has completed task, the next thread will come into existence. Execution sequence, when the synchronous method is created, the executing thread will acquire a lock in this method. So at a time, only one thread will get the things done. So other threads will have to wait. So it's going to happen sequentially. Now the things are not going to happen parallelly. Mutual exclusive. Your synchronous methods provide mutual exclusion, allowing the threads to safely complete their task first. My execution of the one thread is mutually exclusive from the execution of my second thread that is going to come up. So first the task of my thread 1 will be getting completed. It will release the lock, then only my thread 2 can come and do the execution. We also have thread blocks here. So thread blocks give an advantage over your thread method because in thread method what happens is I am synchronizing, I'm blocking the entire method. But what has been noticed sometimes that in my method, only few of the statements are the statements that require synchronized access. Many of the statements can be accessed parallelly without any problem. So rather than you blocking the entire method, inside your method you can block few lines of statement that you want to execute in a sequential manner. So what exactly is your synchronized block? Synchronized block allows the developer to control the access to the crucial sections of your code rather than controlling the entire function. Granular synchronization: by using the synchronized block instead of the entire synchronized method, developer can achieve more granular synchronization, thereby improving your concurrency and overall problems that the parallel processing was giving me. And you don't have to block the entire method, just few statements of the method where you need to avoid the parallel processing. Avoid deadlocks. Proper use of the synchronous block is crucial to avoid the deadlocks. Deadlocks will come in picture when one thread is waiting for one method, and in that method we are calling some other method which is again blocked by another thread. So both the threads are looking at one another to release the lock. Both will not leave it, and that will lead to my deadlock situation, which somehow we can avoid with the help of your synchronized blocks. Just showing you an example of your synchronized thread and synchronized block. So here you can see that in my class counter, we have declared one synchronized method. So we are using this synchronized keyword on the method called as increment method. Within the method increment block, we have created a block called as synchronized. So we are not blocking the entire method. We are just blocking few statements out of that method. So now when we are going to actually call these methods, so what we are doing is we are creating an object of the counter class. We are setting up my runnable interface. Here we are using the lambda expression to do the implementation. So lambda expression, because my run method does not take any parameters, I'm keeping it as empty. The expression is for this for loop, I have to call. So from 0 to 100, I need to call this method, that is my increment method. In the block implementation also, I'm creating a block task. So block task, again what I'm doing is I'm saying for this 0 to 100, I need to call this method called as my increment block method. So I'm going to start all my threads. I'm creating 4 thread object. For 2, I'm giving the method task, and for 2, I'm giving the block task. So what will happen here? When I'm going to do this method task, at the time only one thread can come and do the execution of my increment method. So it will print the values from 0 to 99. Then it will release a lock, and the second thread will come and do the method execution. Whereas in the synchronized block, what will happen? My method is not getting locked. So maybe other than these statements, I have some more statements that can be executed in that method. So these two threads know they can run those statements parallelly. But when the synchronized block statement are to be executed, only one thread at a time can come and do the execution and print the numbers from 0 to 1. So this is how it will be done. Now the last concept we need to understand here is something called as your daemon threads. So daemon threads are the background threads. So many a times there are threads which will be required to be executed in the background, but these threads are completely dependent on my main thread for the execution. As soon as the execution of my main thread completes, these threads will also be killed. So these are not like my main threads where my entire program execution will wait for my main thread to be completed and then only my program will stop. No, daemon threads will stop as soon as the main thread will get completed. So daemon threads are my background threads that does not block your JVM from exiting once all the user threads are done. If only the daemon threads remain, then your JVM automatically terminates. The purpose of the daemon threads are typically to provide you some background task help you need, such as your garbage collection. So life cycle of your daemon thread, if you see, as soon as my main threads complete, my daemon threads will also get completed. How to create a daemon thread? So for creating a daemon thread, once you have created the class object of your thread, you have to declare a thread as to be daemon before starting. You cannot declare a thread as daemon after starting. So before starting, you can declare a thread as to be daemon with the help of this method called as setDaemon. So this is it what we have in the thread. So basically what we have understood is multi-threading is basically used for implementing your parallel processing here to give you more leverage over the execution time and everything. And here in this slide we have understood how to create and how to create the logic for your thread and how to make use of your synchronized keyword also. That's it for today. Thank you everyone. Hello everyone. So now we are going to explore a small program on your multi-threading using an example of a cafe, how it will be working. Like we are placing an order at a time, only one user should be able to place an order. So how that can be achieved with the help of your multi-threading, we are going to implement that. So for that, what we have started off, so let's move on directly to our main function first. So in the main function, we are first starting up a thread that is going to act like my thread for the cleanup. So we have discussed about the daemon thread. So daemon threads are like my helper or my background threads, will be working along with my main threads to do my backend task, to do my background task. So here in the first stage itself, what we are doing is we are creating an object of a class uh, that is called as my cleanup thread. This cleanup thread, we are going to convert it into a daemon thread. So for that, we are already making the changes in its constructor. So look at the constructor of this class. So we have cleanup thread that extends your thread class, and in that constructor of that cleanup thread, we are setting up this thread as to be a daemon thread. So this thread will be closed automatically as soon as all your main threads are going to get closed. In the run method of the cleanup thread, what we are doing is we are just using it to showcase that we are going to do some cleanup task in the background, and we are putting this thread for sleep for almost around 3 seconds, just stimulating the behavior that my cleanup task will be happening for 3 seconds. So this program is just stimulating the behavior that the cleanup in the background will happen for 3 seconds. Then we are creating the object of thread classes, two thread classes. In one thread class, we are calling the runnable interface with the value as 80 and with the value as 120. So what exactly is this? Let's explore into this payment processing runnable. So this is your payment processing runnable. So in the payment processing runnable, first we have declared a variable called as amount, that is a final variable of type double. Now, in order to initialize a final variable, you have to initialize it here at the time of the declaration itself, or you have to do the initialization in the construction. It is compulsory. So here in my constructor, we are initializing the value of this amount variable, my final variable, based on the value that we are passing when we are creating the object of this class, that is my payment processing runnable. So here for the first execution, we are passing the value as 80. For the second thread's execution, we are passing the value as 120. So for both the threads, two different values will get assigned to the amount. For one, it will be assigned as 80. For another one, it will be assigned as 120. In the run method now, and you'll notice that the run method here, we have kept it as synchronized. So when we are making a method as a synchronized, at a time, only one method will be able to execute this run. So if my thread 1 is coming and executing this run method, it will complete its task, give the control back to my whatever thread is waiting. Then my thread 2 will acquire a control on this method and will complete the task. What we are doing in this particular method, we are just stimulating the process of my payment here. So I'm processing the payment of the amount that we have indicated here. So 80 or 120, depending upon which thread is acquiring the control over my main function, and we are printing the name of that thread also. We are stimulating the payment process by putting this thread for the sleep for 1 second, just like how we have to wait online also for my UPI to take some consideration to do some backend task. Here we are stimulating that wait here by using the sleep function. And lastly, once the sleep function is completed, I will be getting this message saying that my payment has been completed for this much amount. We are just associating my thread with the run method. Now we will be actually starting my threads. So my start method will actually tell my JVM to start executing my run method. Now here afterwards, what we are doing is we are also calling this join methods. So this join method is basically used when you want that the payment 1 and payment 2 test task should be completed before the further task of my main method to continue. So I don't want these statements to be executed until and unless my payment 1 and my payment 2 task is completed. So that is the assurity we are getting because of this join method. So join method basically says that let my main thread wait till the task of the thread on which I'm calling this join method is not completed. So basically my payment 1 thread, I'm starting it, let its task be completed. Then my payment 2 thread also started, let its task also be completed. The further tasks will come into place once these two tasks are completed. So my payment task will get completed first, and then my order task will task. So for my order task, what we are doing is we are going to stimulate now the behavior of locking. So for locking, what you can do is you can also make use of an external file called as log file that comes under your concurrent API, that is part of your Java. This entire concurrent API was also added in your Java 8. So out of that, we are going to create an object of a class called as your reintrant log, which is going to create a log and give you the control when to acquire the log, when to leave the log. To use this log, we have created two more threads, that is my order threads. So these order threads are nothing but the objects of my order processing thread. So this is my order processing thread. In the order processing thread, first we are declaring two variables, one order of type string, another one is my log of type log. So we are initializing the values that are coming. So my order is for cold coffee, that is my string value, plus the log which we have created here, and my hot chocolate and the log which we have acquired here. So we are initializing those two values here in my constructor. In my run method, now we have not created the entire run method as my synchronize method. Rather, inside my run method, I have created a synchronized block and I have assigned this log on the synchronize method. So as soon as my synchronized block will be executed, the log will get acquired by one of my thread. So till the log is there with one of my thread, that thread will complete its task of my synchronized block. After the synchronized block has been completed, then the leg will be acquired by my second thread. So this is what we are stimulating here so that my order is getting prepared. So there should be a wait time till my order is getting prepared. So for that wait time, we are stimulating it with the help of the sleep function. So for 1.5 seconds, my order will be getting processed. And once this 1.5 seconds has elapsed, what will happen is my order is or ready to serve will be printed. In my main function, we are also making sure that both my orders which are started here are getting completed before my further processing. So here, before my main method can be concluded, I have to make sure that both my orders are completed. So for that, once again, we are using this join function. Join function will make sure that your order 1 thread and your order 2 thread both are completed before my main threads can be concluded. Then lastly, what we are doing is we are printing the message saying that all my orders and payments have been processed. The cafe is closing. You will also notice that as soon as my main thread is closing, even my cleanup thread is going to get closed. No longer my cleanup thread will be working. My cleanup thread is a thread that is working in the background. So now let's simulate this and execute it and see what is the result we are going to get. So I'm running this program. So you can see cleanup in process. So periodically my cleanup in process is coming. So cleanup in process for 3 seconds. So in the background, here first the payment process of my threads will be completed. Then you will be executing the process of your orders. The payment is getting completed. Your order is getting served. Then your hot chocolate is getting prepared. Then your hot chocolate is getting served. So you can see in between my hot chocolate is not getting prepared. So first I'm starting one order, then I'm completing that one order, then I'm starting with one order, then my second order is getting completed. My cleanup is working in the background. In middle my cleanup is getting worked on, but my cleanup is not stopped. We are not taking care of cleanup being stopped because that is anyways my daemon thread. And as soon as my main application is stopping, my entire program along with my daemon threads will be stopping. So this is just giving you a small stimulation of how my payment and my order process will be working. I hope this code has been useful for you. Thank you everyone.